All right. How are you doing today? Let's get in and talk about databases and data formats. Um, what I want to talk about is, let me share my screen. I get this question a lot about how to design events, how to design aggregates if you're doing DDD. There was a recent conversation that went all over the place about this. And and a lot of people know, the major system that people have used for a long time now have been relational databases. There's been some big traction in certain areas with document databases, right?
Yep.
And there's been a bunch of traction on key value stores, and there's been a bunch of traction on graph databases.
Yep.
Right. But all of them come from the same fundamental principles of data science and data structures, right? And when you understand what those core goals and constraints and structures are, then you can really see how, once you understand how the structure of a relational database was derived from the fundamental properties,
Yep.
you can then see how it's rederived into stream databases, event stores, how it's rederived into graph databases or document databases, and so on and so forth. Because the computer science problems that we're trying to solve are the same. We're doing the same things. There's nothing new here. So, and once you understand that, you can then, the great thing is you bring all your tools. Everything you've learned about data modeling in a relational world, once you understand the transforms, applies in event source world.
Yep.
And one of the things that I find interesting is most people seem to come at this with a concept that they are losing structure and they're losing modeling that they had in a relational model when they come to event sourcing.
Yep.
Right? And the truth is the inverse. Properly constructed, there is a much richer modeling structure available in event sourcing. More data is retained, more data is recorded.
Yep.
So it's not just about, we don't delete anything. That's very true. But we also add more information in. When I do a set operation in a relational database to do an update. It's an update. That update is ephemeral. Right? In an event source system, that update has a name. And it's recorded with the name.
The
So
event type.
now I have an additional piece of information about what that update was all about. Right?
I guess you mean the event type now.
Yeah. The event type, the name of the event that you wrote into the log to represent this change in state, it has an additional name on it.
Yep.
We also, as we use Event Store, in Event Store, we've got the concept of event type streams. So events of those types are now projected. So you now have those as cross-cutting segments. We also have categories, right? And a category is a higher level structure. It's a more complicated and richer structure for modeling than the pure relation and relation set model. So let's, before we get into that, because I'm just making that as a broad assertion, let's go back and talk about what's going on in a relational database, right? And then we'll see how the equivalents show up in an event store.
Yep.
Okay? So the name relational database, most people nowadays I talk to think that the name relation is because you can do primary and foreign keys. They think the relationship between the tables is the reason it's a relational store. And that's actually not true. The relational database refers to the row. And what it says is that each of these data elements here is a relation. So the row is the fundamental element in a relational database. And the organizational choice of those relations in a relational database is into like sets. So I name a set of relations with a matching schema, right? A matching set of columns, and then they call that a table.
Yep.
And then the SQL language is all about being able to perform set operations on a set of relations with a matching schema.
Yep.
And then the foreign key, primary and foreign key constructs in a relational database then allow you to do multi-set and cross-set operations, right? And, whenever you have, the reason why your DBAs lose their mind when you have a cursor in your store procedures is because you're not using them as sets.
Yeah.
All of a sudden, you're not doing a set operation. You're doing a row operation, and you're iterating through all the rows.
Yep.
So you're losing all of this beautiful, highly evolved set logic, right? And the query plans are about how to group the sets to then perform your operation on all of the sets. But again, when your query's done, the query's thrown away,
Yep.
right? Be it an update, an insert, whatever. So what happens is we have a name, we have a query, it gets run, then the running of that query or statement, probably statement's a better word there. The running of that statement produces a change in the database. The effects of that change are then recorded in the transaction log, and then the contents of the transaction log are applied in series to the database, right?
Yep.
And then once they've been successfully applied to the storage system of the related sets of data on disk, that transaction log is truncated and thrown away. Sometimes that transaction log is used for replication. So what they do is they don't replicate the core data or they don't diff the data. They just replicate the transaction log right out to other things, which is very similar to what we do in the event store.
Yep.
So
just for the record, there's an excellent book talking about those topics from Martin Kleppmann.
Oh, nice. Yes.
Yeah.
Turning the database inside out.
Yeah. So that whole book on that topic is quite clear, and also the caveats and the pros and cons of all the approaches. So that's a nice reference for people who want to dig further into that.
Right. So now let's talk about what does that mean in an event-sourced world. Okay. So first, I'm going to make a couple of assumptions. I'm going to make an assumption that you're not using a log, an undifferentiated or log where everything's in a one giant lump, right? We're talking about fine-grained streams and fine-grained events.
Yep.
Because that is the appropriate parallel to a third normal form model. And what we're really talking about here is how do we append data into the store? So as we read data and we consume it and we query data out of the store, we're going to prefer first normal form structures. We're going to reach from all these little tiny streams, pull them together, and give you nice broad answers. The same way you do in a relational store. If you think about a reporting warehouse, or even a first normal form table, or the outputs of a query, right? It reaches out to a whole series of tables, pulls everything together, and updates it. The benefits of something like third normal form is third normal form is about, nominally it's about not repeating yourself. It's about having a nice, tight, non-repetitive data structure for size. But that also forces some other good constraints on you in the relational world about, if I've got something where I've pulled payment status out, as you see here, right, and I've pulled line items out, now I've got one place that owns the line item data, right? The line item ID number is in one place. There's one owner for that. And that's another really significant benefit to that, that normalization and modeling of your data, right? So I have one logical place to see my line items IDs, right? The ID here, like ID 4 is for invoice number 2. That's going to be line item number 1 on invoice 2.
Yep.
But it is the 4th line item in the database from data modeling. So we want to do that same modeling of it. We're winding up, we're not building tables with hundreds of columns. We're not building one table with all our data, right? I literally remember one guy at an insurance company said, all we need is 2 tables. With 2 tables, we can model the entire enterprise and blah, blah, and it's like, but you lose so much and you're just talking about a trail of tears, right? That's the same as like, I'm just going to put random events as they occur to me in Kafka and listen to them, or the Azure Service Bus or whatever, right?
Yeah, no, that's not going to work. And I've seen attempts like that also with where they try to, where there was like, so SQL relational tables also like describing, oh, this is the key, this is the type of value, and then another table that kind of with 3 columns of something that have all the entities, and it's like one table with all the entities, and which is basically making a database in a database, which is strange.
Right, and it's not very efficient.
And it's not very efficient.
Right. It's like when people ask me, well, why do we want to go with a event store versus doing something like SQL Stream Store, right? It's like, okay, well, I mean, that's going to work well, but what happens to your indexes in a relational database when I want to be able to append to any one of 24 million streams with a sequential ID?
Yep.
Right? Without a purpose-built solution to handle those cases, everything starts to fall apart.
Yep.
But let's get back to what we're doing here. So
yeah,
we need the fine-grained stream so we can do our data modeling. We want fine-grained events for our internal data. Data on the inside and data on the outside still applies, right? We don't want to share this private fine-grained schema with the world, but that's how we want to model it inside of our app. So I want now the equivalent in event sourcing for data modeling is the relation is an event.
Yep.
Okay. And the difference is that we don't enforce that all events of the same type. So the next level construct that we have is the stream. And the stream represents the order in which events are applied, right? So a set of events are applied in a particular order, and those events have names. So whereas here, I might just do an update on this row and replace the row with something new. In event sourcing, I would apply an event to a stream, right? And that event's going to have a name for what kind of update was this, right? And there's going to be a set of events that go into a stream. So this brings in the concept of a category. And you can see the category here. Like you can see clearly that I have customers and I have invoices, right? So if I roll over here, right, and we look at this, we can see that I've got one category of customer and one category of invoice. So in this model, any invoice stream, so a category has multiple instance streams, the same way a table has multiple rows, right? So for each instance, I would have one category stream. So invoice -1 would be this first invoice.
Yep.
Invoice -2 would be this second invoice. The invoice streams would all accept 3 types of events. They would accept created events, line item events, and payment status. Now, in truth, it's probably going to be more than that, right? But if we're talking about this one-to-one modeling,
Yep.
there's a set of event types that are allowed in the invoice category of streams.
Yep.
And there's a separate set of event types that are allowed in the customer categories of streams. All right, so that's the, and then what we say is, okay, so at the category level, I'm going to define the event types that are allowed, and I'm going to define the schema of those events. So, and that's how I'm going to start developing my data model. So now I've got this cross-cutting concern. There's nothing in a relational database that tells me, other than reading the keys, that invoices, line items, and payment status all pull together to really form a single thing, which is an invoice.
Yep.
And there's nothing in there naturally that gives me a history of that invoice. So with proper data modeling and event systems, I get this business concept to extract it out of the mechanics of the database of an invoice. I get a history of it, and I get named changes to it over time.
Yep.
And those all model to either updates or changes or inserts into these rows. So what we would see here is that category customer, I would have customer 1 and customer 2. I'm going to have an add customer event, and then I might have a terms extension negotiated event, right, which might be different from a correction event.
Yep.
Right? It's like, there's a very big difference between, we got it wrong and we had to update it, and, we renegotiated, and terms are different, right?
Yeah.
Because when I'm applying it, if it's just a correction, I need to backdate it as if it was from the beginning. But if it's negotiated, any outstanding invoices, this doesn't apply to, right?
Yeah. And probably, just if I have an app that is based on a relational model and building a database, probably the case of term extension negotiated will be, the use case itself will be described and in the...
Actually, most relational systems I know, if they were trying to make that change, they would either say you can't enter into the database until it's effective, or once you enter it, it's effective for all time.
Yep.
Right.
The point I want to go to is I made a mistake typing it in.
Oh, right.
Where there's someone in support that needs to take the fire hat. I'm going into the database in production to correct a silly mistake someone made.
Right.
Which is something you can't do with an event source database. You have to take into account that kind of stuff as well.
Yeah, so here we've kept that information about the history. We've got that audit trail and what's going on, and we can do as of and as at if we need to off of this data. And it's not like the other thing, which I'm assuming here, is that we're really talking about data modeling in a database, right? Like Event Store is serialized, linearizable, or linearizable. I forget which order he says it. But the top
strict
level,
serializability.
It's strict serializability, right? So, and that means it's linearized and it's serializable and will always be repeating, because there's a very good argument out there that you can't do this history stuff if you're just doing accepts.
Yep.
right? If there's no way to discriminate between what order things happened in, if I'm saying this is a guaranteed order, I can't accept conflicting changes and apply them both.
Yep.
Because that's going to blow everything up. And then over here, we see the same thing with the invoice. Now we're seeing add invoice and add line item, which would have been on a different table in the third normal form. And we have payment received. The other thing which is interesting here is in a very similar manner to how we do foreign keys in third normal form. We want to use the IDs to reference other categories,
Yeah.
right? I want to put in the, I'm using Mike here, but that's a key to this other record, right? So
Yeah,
I
it
don't
could be
want to put,
customer one, could be customer A, and so in invoice number one, if you go a bit down,
right?
let's say customer one has an ID of, instead of one, it's A. So in the add invoice, the first one would be A. Oh,
Mm-hmm,
it's an invoice for customer A, which is called Bob Styles commercial.
right. So, because what I see sometimes people do is they're thinking about what they need to put on the screen when they're creating their events and what they're modeling. And so I'll oftentimes see people put it then the current display name of the customer on the event with the payment received, right? So this payment received, well, that payment received from Mike Smith. But the problem is if Mike changes his name, Mike gets married and now he's Mike Jones, right? That's going to be wrong.
Yep.
Right. So what you really want to do is you just want to reference that surrogate key, which is the ID number of the customer. So what I really want in here is customer two paid.
Yep.
Right. And then I can pull together from all of these streams into my UI. And at that point, the other thing to keep in mind is that we've got the stream, which is a guaranteed sequence. We got the events in the stream, which all should have known schemas. Shouldn't be a free for all, right? We've got the categories, which group those streams by the allowed event sets with the known schemas, or those are our relation sets, but they aren't uniform. And then we've got the all stream, which is really the log. And what that does is that allows us to, we got a helicopter doing a flyby here.
Oh,
I don't know if you can hear that or not.
yes.
That was a little bit weird. So then we got the all stream, right? And the all stream provides order for every single item in every stream. So I've got the order things happen in my fine grained streams, and then I've got the order across the whole database. And that guaranteed order and that guaranteed linearizability is what allows us to know when this invoice was paid, what was the name at the time, how did it change, the term extensions negotiated, all those things are comparable between streams because of that ordering.
Yep.
Um,
That,
so
that,
yeah,
that yep.
go ahead.
There's one interesting thing here, but because we have like the stream. I mean, in the design of the stream model, you have add invoice one. Add invoice number one. I guess the number one is for customer one. I have March and goods.
Oh, I was just copying the data over. So that's
Yeah,
the ID number of the invoice.
that's the ID number of the invoice.
Right.
Okay.
So this set
What
here
I've seen people do.
matches exactly to this set here.
Oh yeah. Okay.
One-to-one mapping. So
Yeah.
it's ID, client ID, date, description.
Okay.
Right?
What I've seen
Well, actually, so
people.
no, the ID is here.
Yeah.
So this ID maps to invoice one.
Yeah.
This client ID here is that ID number there. This date is this date, and this description is this description.
Yeah.
That's my
Yeah.
reference to this customer number one.
Yeah. And what is interesting, the add invoice event doesn't have the invoice ID.
Right. Because the invoice ID is in the column, is in
Yeah,
the stream.
is in
Yep.
the stream. And when you get back that information, the information you get is not only the event, you get the stream, the event, reading the all stream or reading a specific stream, but you always or should always get at least the stream, the event, and the metadata
Right.
that comes. But you have that stream and you have the position in the stream or in
Yep.
the full log. So that's a full information set you need to be able to have that kind of fine grain model without repetition, actually.
Mhm. Yeah. Yeah, I normally put the ID in the events, but that's just a convention I use for because it makes some things easier.
Mm-hmm.
It's certainly not required, and you absolutely do have all of that information available in the stream. The reason I do it is there's another set of virtual streams that you're going to get, especially if you turn on the standard projections, and that is I can have an event type stream, which is a projected stream, which cross cuts this category,
Mm-mm.
right? And in that, I could have all of my invoice added events. So if I wanted to look up a particular invoice, I would subscribe to the I would turn on normally I would turn on the standard projections. I would read an invoice created event stream, create a read model that was easily searchable, and once I get the ID, I would then use that ID to generate a query on the exact stream that I want.
Yeah.
So every time I'm doing very targeted stabbing small searches for the data that I want. I could do a read model where I read the entire invoice category, which would give me every event on every invoice everywhere. But most times it's much more efficient to be able to go, okay, I'm going to just look up on the createds, right? Or I have another read model, which might be like my invoice, top level invoices read model might have like the invoice ID, the payment status, the date, and the customer, because those are what I search on.
Yeah.
So I create a read model with just my search criteria that allow me to find a particular invoice and bring it up.
Yeah.
And that gives me this really nice, tight, fast,
Query.
fast way to do it. And then because I've aligned everything into these individual streams, when I want to do something like say, okay, all the invoices from last quarter are now closed, I can then archive them and move them out of the store.
Mm-mm.
So I write them into a different store. I might even write them summarized. I might, decide, you know what? All I need for audit is the final invoice status, right? And that final invoice status is effectively a snapshot of the end state of the invoice. I'm going to put that somewhere with a key where I know how to get it, and then I'm going to truncate this stream.
Yep.
Right? So what I would do is I would write an archived event into the invoice stream with the details of where to find the event if I wanted it. And then I would truncate all the events before that archived event.
Yep.
Right?
Closing the books.
Closing the books. Right? And then having that event be a pointer to where you need to go to find it. And I would also, of course, have a backup of the whole event store someplace if I need to look at something, right?
That's under practice for any
Right.
database.
The other thing which I find is that, like if I had a customer stream, right? And in my customer stream, I wrote, so some people say, well, I would just say, I've got a customer, my customer's invoices. I'm not going to add any complexity that I don't need. So all my invoice events are going to go on my customer stream because it's simpler.
Yeah.
And to some degree, it's simpler. But the problem is that how do I do data maintenance on my customer? Right? I can't truncate that customer stream because the first event in the stream is setting my customer.
Yeah.
Right? And I've also, like what if we have a request to be forgotten on this, right? and this customer wants to be removed from your system. Well, my invoice information is part of my accounting data. I can't delete that.
Yep.
Right? But I do need to be able to delete the customer identifying information. So what I really need to be able to do in that model is maybe have a separate stream where I create a customer, I create a stream of customer identifying information that I reference to my customer stream, and then my customer gets referenced to my invoice. So I can wipe the identifying information, but still have all of the invoice information.
Yep. And probably even because, I mean, the model is highly simplified here. Customer, it depends actually if we're talking about what type of customers. If those are private person or companies, and if it's companies, you have relations or points of contact.
Right.
So it's an entirely different model than for private persons.
Right. But if you just have identifying information someplace else in a stream by itself, that can be truncated at will. And rather than just truncating, maybe you do a tombstone which says some identifier to use, remove person number 992.
Yep.
Whatever. So you have a label you can put everywhere and still use it, but you don't have the identifying information about that person. The other thing that I find people aren't really paying attention to when they worry about GDPR and these data modeling things. One, this is just as complicated in this relational model as it is in an event model, and more difficult, I think, to model this way, because the same solution I do here, where I'm saying create another stream with identifying information, that's exactly what I would do here. So I would create another table. I have a foreign key reference. It's the same exact data modeling problem here. And then the other one is people are the right to be forgotten is about removing tracking data. It's not about legally required information, right? If my stockbroker quits his company and says, "Hey, I want to be forgotten," they're just going to laugh at him. They're like, "Oh, no. Your name and your ID are on every trade that you executed forever," right? There is no right to be forgotten about things that are legally required.
Yep.
Right.
I have an actual case where, and it's about private personal data. And if you did some action in the system, participated in certain things, we are actually legally bound to keep that data for 16 years.
Right.
At least.
Right.
And sometimes until the person is, passed away. And that's government stuff, but we have those regulation also, and it's funny that you mentioned that, because we have like the technical possibility of okay, move that data away somewhere where you can truncate it or remove it or forget about it. And I just want to say one thing about that, because I think that's important. The point you made about what are the legal requirements we have about that information, that is something that probably the security officer knows about and the legal department knows about, or the DPO in Europe, the data protection, knows about. So those are your primary users, or domain experts. And the first thing you should do is talk to them before trying to implement something on your own, which will not be correct on the process side, because the right to be forgotten is not an application problem. It's a business problem, and there's a lot of people involved and a lot of processes around them. So that don't try to do that on your own and treat it as a technical only issue.
Right.
That was my rant for the day.
Well, one other thing that I want to talk about is event versioning. And as long as you're using a weak schema, JSON's great for this. The same rules where you see all the time where I can add a column to a table as long as it has a default value. That's extending and modifying and versioning the relation.
Mm-hmm.
Right? If the relation is defined by the columns that are included in it, add into a column to a table is versioning your relation schema. The same rules apply to versioning events, right? It is a very simple matter for your program to add additional elements or to skip elements in an event, and then just as you deserialize them, upcast those into the newer versions, right? So a definition of an object which has more fields can easily serialize from an event that has fewer fields,
Yep.
right? As long as you have, you know, the default values, which is the same thing you would do in a relational database.
Yep.
So all of those same tools still work for you. All the same processes still work. So just to recap briefly, right? When we look at our relational model, we understand that the fundamental data element is the relation, which is a row. Those rows in a relational database are grouped into sets called tables. And it has a constraint that all relations in a set have the same schema, which is defined by the columns. And then you can join those sets with primary and foreign keys as a feature to support a more rich query and statement language. The same rules about defining third normal form or right side schema apply when you're doing a proper stream database, something with fine grained streams. Like, we easily handle tens of millions of streams in Event Store, the same way a database would handle tens of millions of rows.
Yep.
In the event based system, we have a couple of things that we add in. We add in additional modeling around what we call a category, right? And that category is now a set of relation definitions or a set of events that all apply within a particular category, which are then grouped into different stream instances. Those stream instances will hold the history in guaranteed sequential order, right? It's always 1, 2, 3, 4, right? And each entry or change will have a name, which is the event type. So we're gaining information on history, we're gaining information on why the change was being made, we're gaining information on these grouping constructs that are unavailable in relational databases around a category. And then from there, all the same rules apply. I want to have one place that owns a piece of data. Don't put the data in two places. Pick one model and the data is owned there. Generally, you'll have a category will own a set of data, which is the union of all data in all of the events in a category. So if I take the events I've defined, which are my relations, take the union set, that's the data ownership for a category. And data ownership should only be for each piece of data in your system in one category. And that's the heart of creating proper invariance and restrictions and modeling. And much like poetry, constraints help you create better systems.
Yeah.
Not repeating yourself gives you a better model. Because when you can't do that, that means your model's wrong.
Yeah.
So
That's cool. That means I can take all my best modelers in the relational world and
yep,
use them to have my best model in the
100%.
event model, event data model world.
Right.
We need to find a better name. But that's cool. That's really cool. Thank
Right.
you.
And that's why people have done this a while get upset when they see invoice updated as event type, right? Because you're not using that additional modeling
Yeah.
for why was it updated, right? And that's what we see here with like, term extension negotiated is why this was changed.
Yeah, but my best guess is that my best relational modeler would want to be able to do that in their relational model, but now they can.
Absolutely.
They can.
Right.
They can have best of both worlds.
And it's also very easy once you've done this to then project this into a first normal form reporting database. The fact that the all stream has a single position in it that represents the stream to that point as a vector clock means that your cache and validation problems with updating target systems are now trivialized.
You will need to explain that another time, Chris,
Okay.
because that's a whole topic in itself.
So in a nutshell, a lot of the pain about running multiple data models is around cache invalidation. And the use of vector clocks in the database and the use of the all stream allows a tremendous simplification of all of the models. So rather than having one giantly complicated thing, I want to have 5 really simple things that have very simple and easy failover and setup. And it is actually lower complexity, lower effort. It's easier because you're not violating the single responsibility rule anymore.
Yep.
But again, another topic.
Another topic which will need some drawing, so be prepared.
All right, I think that wraps it up.
Yeah, that wraps it up quite correctly. That's cool. Thank you very much.
Yep. All right.
And next topic will be something interesting.
All right.
All right, thanks. Bye.